Let us now find the power factor of a rectifier capacitor filter circuit. Only by looking at or only by using the measured voltage and the current wave shapes on an oscilloscope. So let us say we have an oscillogram with the x-axis the time axis, and let us put a voltage wave shape. The voltage, the input voltage to the rectifier capacitor filter is a sine wave because we are taking it from the AC source, and it has a peak maximum amplitude of Vm. Superpose the typical rectifier capacitor filter input current wave shape, which is like that, and this is familiar to us. We have this here. Now the peak value, what is the peak value? This is the peak value, Im for it. Now if you want to compare it with a resistor, a pure resistor will be having the same wave shape as the voltage, and you should adjust the resistor value such that the peak of that current should be same as this Im, like this. So we have two sets. One is the unknown rectifier capacitor filter load. The other one is the benchmarking R load, pure R load. Voltage wave shape Vm and voltage wave shape Vm, same for both R. The capacitor filter load measured on the oscilloscope gives an Im, which is this value. Use that same Im and draw the resistor current wave shape like this, having the same Im magnitude and having the same wave shape as that of the voltage. Then it is a pure resistance. Now the power. Multiply the instantaneous values of the current and the instantaneous value of the voltage for a given time point and place the power points. So for the resistive load, we have seen that this is the power curve, instantaneous power curve, and for the rectifier C filter, this is the power curve, because the currents don't flow on any other periods of time. So power is zero. The power is going to flow only during the period of the time when the diodes are conducting and there is a current flow. Now compute the average. The average in the case of the C filters, P load or P naught or V naught into I naught. DC output is DC and therefore easy to compute. P load is the average. In the case of the R load, we know that PR is Vm Im by 2. So let us remove the voltage and current and retain only the power wave shapes with the averages. Move up the wave shape a bit, and then we know this is Vm Im by 2. How do you find P load? As I told you, P load can be found from the output wave shape of the capacitor rectifier filter. V naught is a DC, I naught is a DC, V naught into I naught will be the average power. Or you could on the oscilloscope compute the instantaneous, if you want to include the ripple, if the ripple is not negligible, compute the instantaneous value of I and P, I and V, and find the value of P and then average it. I will just let you know how to do that just few moments later. So we can find that, of course, by measurement on the oscilloscope. So P load can be found out, and once you know that, combine these two. PF is P load by PR, so which is 2 P load by Vm Im. So this would be the power factor equation for the rectifier C filter. Let me now briefly tell you how to measure average power so that you can measure P naught or P load from the oscillogram and use it for computing the power factor. Now consider that this is an oscillogram. You have the voltage wave shape and you have the current wave shape, the inputs of your diode rectifier capacitor filter circuit. Now you mark points, tick marks along the x-axis, the time axis, and number each of the tick points 0, 1, 2, 3, so on till you have n. Now at any point k, at the kth tick point, if you take this point on the voltage curve, you will get the value of voltage at that point, kth point. We call it as Vk. And if you measure the value of current I at that point, it will be Ik at time instant k. Like that, you have to measure for every time instant and tabulate. So let us make a tabulation. Let's say you have one column for k, one column for Vk, one column for Ik, another column for Pk, where Pk is the product of these two columns, Vk into Ik. This is the instantaneous power. So for the first point, correspondingly take the I and the V value, V1, I1. In this case, I1 would be 0, Pk. Second value, V2, I2, and you will get P2. So on for the nth value, Vn into Vn, In and Pn, which is Vn into In. Then take the sigma of the power columns. The P average or P naught or P load is equal to sigma of all this, sum it up, sigma of Pk, k is equal to 1 to n, divide by number of samples, which is n. This will give you the average power directly from measured wave shape on the oscilloscope. This P load value, you plug it into the power factor formula equation to get the power factor for the rectifier capacitor filter circuit.